Hello, this is Mr. Barr, and this is using the explicit arithmetic and geometric formulas, also called using the explicit formula. Our learning goal, I can use exponential functions to model real-life situations. Exponential functions show up in science and economics. I want to understand how they are used. I do not have any magical intro text for you on this one. So let's get going with the notes. And our title, well, you're going to start with their name, but the title is going to be using the explicit formula. Not 4. So somehow this function creates this sequence. Somehow that creates this. How? How does this create that? It's actually a slope-intercept equation. I'm going to plug in a 1. If I plug in a 1, 6 times 1 is 6, minus 1 is 5. I plug in a 2, 6 times 2 minus 1 is 11. I plug in a 3, so I plug in 1, 2, 3, and 4. I plug in 1, 2, 3, 4, out comes 5, 11, 17, and 23. It's actually, I plug in n's and I get out t sub n's. To find the value of the first term, plug in 1. To find in the value of the second term, plug in 2. In this case, it's an arithmetic. This is arithmetic. But here's another one. T sub n equals 3 times 2 to the n power. And in this case, out comes 6, 12, 24, 48, right? Times 2, times 2, times 2. So it's geometric. How does it create this sequence? Well, how? Plug in 1, 2, 3, 4. I plug in a 1. 2 to the first power is 2 times 3 is 6. I plug in a 2. 2 squared is 4 times 3 is 12. I plug in a 3. 2 to the third is 8 times 3 is 24. Plug in a 4. 2 to the fourth is 16 times 3 is 48. I plug in 1, 2, 3, and 4, and out comes this geometric sequence. So the bottom line is you plug in n's, out comes t sub n. It's kind of like you plug in x, out comes y. You plug in n, out comes, we're going to be seeing also a sub n's. You plug in the domain, Out comes the range. It's just a function, and we've done functions, but now we're just doing very specific functions called an arithmetic and a geometric. But you plug in x's, out comes y's. You plug in n's, out comes t sub n's. It's just, remember f, you plug in x and out comes f of x, right? It's just another way of showing a function. I plug in 1, out comes the 6. I plug in 2, out comes the 12. I plug in 3, out comes the 24. Plug in 4, out comes the 48. All right, so what we're going to do is we're going to use this explicit function, and we're going to find the first 4 terms, and I'm starting with n equals 1. All right, so I plug in a 1. Out comes 8 minus 7. If I plug in a 1, out comes a 1. If I plug in a 2, 8 times 2, 16 minus 7, out comes a 9. I plug in a 3. 8 times 3 is 24, minus 7 is 17. What's happening each time? It's going up by 8, right? Plus 8, plus 8, plus 8 would take me to 25. Plus 8 would take me to 33. It's going plus 8, plus 8, plus 8 right there. That's the common difference. Plus 8, plus 8. One, 9, 17, 25. Okay, this one. So we'll plug in a 1. 4 to the first is 4 times 4 is 16. Let's plug in a 2. 4 squared is 16 times 4 is 64. Let's plug in a 3. 4 to the third power is 64. 64 times 4 is 256. Now, really, at this point, I don't have to use the function anymore. I just have to keep multiplying it by 4. Times 4, times 4, times 4. 16, 64, 256, 1024. All right, let's find the first 4 terms of this. Plugging in a 1, 3 plus 5 is 8. Plugging in a 2, 3 times 2 is 6, plus 5 is 11. What's going on? It's going plus 3, plus 3, plus 3, plus 3. 8, 11, 14, 17. Plug in a 1. 1 minus 1 is 0. 2 to the 0 power is 1. 2 times 1 is 2. Let's plug in a 2. 2 minus 1 is 1. 2 to the first power is 2. Times 2 is 4. So it's going up by 2 each, or it's going times 2, times 2. Let's plug in a 3. 3 minus 1 is 2. 2 squared is 4. 2 times 4 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. 4, 2, 4, 8, 16. That's working. And that's it. Let's get this into our notes. Remember, anything to the 0 power is 1. No. Hopefully that's in your brain by now. That's it. Thanks for watching.